Welcome to this training session on indirect, antifreeze, active solar thermal systems. In this presentation, we'll explore how these systems work, their main components, installation considerations, and ways to maximize performance and energy savings. By the end, you'll have a clear understanding of why these systems are a popular choice in cold climates across the United States. Before we start about indirect solar thermal system, let's have a brief idea on the available types of solar water heating system. Types of solar water heating systems. Solar water heating systems are classified into four main types. Active systems use electric power to run pumps and controllers that move the fluid between the collectors and the storage tank. Passive systems operate without pumps, relying instead on natural buoyancy, also called thermosiphon. In these, the tank is often placed above the collector, or the storage can be integrated directly into the collector itself. Direct systems heat potable water directly inside the collector, which is then stored and used as needed. Indirect systems use a separate heat transfer fluid, such as propylene glycol, inside the collector. Heat is transferred from that fluid into potable water through a heat exchanger. Each approach has unique advantages depending on the climate, maintenance requirements, and installation constraints. A solar water heating system is made up of several key components: solar collectors, a thermal storage tank, system controls, and a backup conventional water heater. Here's how it works. Sunlight strikes an absorber surface inside the solar collector, heating it up. Water or a heat transfer fluid flows through tubes connected to the absorber and picks up that heat. If a heat transfer fluid is used, the energy is then passed to the potable water through a heat exchanger. The heated water is stored either in a preheat tank or in a conventional water heater tank until it's needed. Thermal storage is essential because it balances the timing of available solar energy with the hot water demand in the home. As a general rule, 1 to 2 gallons of storage per square foot of collector area is adequate. For small systems, storage is typically provided by glass-lined steel tanks. Although all solar water heating systems capture and transfer solar energy in similar ways, there are three main types of collectors, each suited to different applications. Low temperature, or unglazed collectors, usually operate up to about 10 degrees Celsius, or 18 degrees Fahrenheit, above the surrounding air. They're most often used for heating swimming pools. These collectors are made of UV-stabilized polymers, with water passages molded directly into the absorber plate. Because the pool water is usually colder than the air, insulating the collector is unnecessary. These are the least expensive option, costing roughly $10 to $40 per square foot. Mid-temperature or flat plate collectors are the most common choice for domestic hot water. They can heat water between 10 and 50 degrees Celsius, about 18 to 129 degrees Fahrenheit, above ambient temperature. They consist of a copper absorber plate with copper tubes welded to it, enclosed by a cover glass and insulated with fiberglass or polyisocyanurate. To reduce heat loss, the absorber plate often has a selective coating like black nickel, which maximizes solar absorption while minimizing thermal radiation. These systems cost about $90 to $120 per square foot. High-temperature systems use evacuated tubes for excellent insulation, sometimes combined with curved mirrors to concentrate sunlight. They can achieve much higher temperatures, making them suitable for absorption cooling, power generation, or large-scale commercial and institutional water heating. Because they often require sun tracking mechanisms, these systems are typically mounted on the ground. Evacuated tube collectors cost around $75 per square foot, but with mirrors and scale, the cost can drop to about $40 to $70 per square foot. Efficiency varies by type. Unglazed collectors are very efficient at low temperature differences, but lose efficiency quickly at higher temperatures. Flat plate collectors perform better for medium range applications, while evacuated tubes are the best choice when higher water temperatures are required, such as for cooling or industrial processes. They consist of a copper absorber plate with copper tubes welded to it, enclosed by a cover glass and insulated with fiberglass or polyisocyanurate. To reduce heat loss, the absorber plate often has a selective coating, like black nickel, which maximizes solar absorption while minimizing thermal radiation. These systems cost about $90 to $120 per square foot. High-temperature systems use evacuated tubes for excellent insulation, sometimes combined with curved mirrors to concentrate sunlight. They can achieve much higher temperatures, making them suitable for absorption cooling, power generation, or large-scale commercial and institutional water heating. Because they often require sun tracking mechanisms, these systems are typically mounted on the ground. Evacuated tube collectors cost around $75 per square foot, but with mirrors and scale, the cost can drop to about $40 to $70 per square foot. Efficiency varies by type. Unglazed collectors are very efficient at low temperature differences, but lose efficiency quickly at higher temperatures. Flat plate collectors perform better for medium-range applications, while evacuated tubes are the best choice when higher water temperatures are required, such as for cooling or industrial processes. Indirect solar thermal systems are the most common choice in freeze-prone areas. Instead of circulating water directly through the solar collectors, these systems use an antifreeze solution, usually propylene glycol. Heat is transferred from the antifreeze to the storage tank through a heat exchanger, which may be inside or outside the tank. The circulation loop is sealed and pressurized, typically around 20 to 30 pounds per square inch, which reduces flow resistance and ensures reliable operation. The antifreeze solution must be checked and replaced every 3 to 5 years to maintain efficiency. Solar collectors are generally mounted at an angle close to the site's latitude and oriented south to capture the most sunlight. Mounting can involve brackets or racks, and attachment methods include spanners, truss lag bolts, or J-bolts. For roofs with metal or tile finishes, special hardware may be required. Proper mounting is critical for both performance and long-term durability. The system relies on a controller to manage pump operation. 2 temperature sensors are used, one at the collector outlet and one at the bottom of the tank. When the collector is about 8 degrees Fahrenheit warmer than the tank, the pump activates, circulating fluid. Correct sensor placement, weatherproof connections, and UV-rated wiring are essential for reliability. Ball valves are also preferred for servicing, as they avoid flow restriction. For the homeowner, clear documentation is important. A durable manual, along with warranty information and product registration, ensures the system is maintained properly. To maximize savings, the goal is to minimize the use of backup electric heating. Timers or dedicated cutoff switches can help limit auxiliary element activation during peak solar hours. Optional sight glass meters can confirm pump operation, while some advanced controllers provide built-in monitoring and energy metering features for added feedback and peace of mind. Before installation, the utility room should have enough space for pumps and gauges, and provisions must be made for bypass valves, wiring chases, and proper architectural drawings. System selection should be based on certified products. Look for approvals from organizations such as the Solar Rating and Certification Corporation, the International Association of Plumbing and Mechanical Officials, or Energy Star. Installations should be carried out by NABCEP certified contractors, and local building and plumbing codes must always be followed. Plumbing design is also crucial. Collector piping should be kept short, ideally under 25 feet, and routed through insulated chases or attics. Exterior piping can be hidden in architectural enclosures for protection and aesthetics. Attention to detail in these areas ensures better efficiency and reliability of the system. In summary, solar water heating systems can be active or passive, direct or indirect, and each has its place depending on climate and application. For freeze-prone regions, indirect active systems are the most reliable choice. From proper mounting and certified equipment selection to careful control settings and minimized auxiliary heating, each step contributes to long-term performance and homeowner savings. By following best practices in design, installation, and maintenance, builders and homeowners can be confident in achieving both energy efficiency and durability from these systems. Thank you for joining this session, and I hope this overview helps guide you in implementing solar hot water solutions with confidence,